This is the boiler. Here, water, flow rate, liquid, water will enter here. Steam will leave here. This is steam flow rate. Here, we have to, water and all has to be controlled. Level in the boiler is important because if level increases, pressure inside the boiler will increase. It may burst. That's why level should not increase beyond certain level for safety. It should not fall below. If it falls below, temperature inside the boiler will increase beyond unsafe value. That's why the level inside this boiler has to be maintained. So level control. For that, you can employ a direct level controller to adjust this flow rate. How it will be adjusted? This flow rate of this will be adjusted based on the level control output. Level control output. A level set point will be given. This is conventional controller. In addition to that, we can implement a feed forward controller. What are the disturbances may enter into the process? One is depends upon the demand, steam flow rate will be there. That's why any change in steam flow rate, we can implement a feed forward controller. So the steam flow rate is here. We are putting a flow transmitter and we are measuring the steam flow rate. If any increase in steam flow rate, feed forward controller will adjust the liquid flow rate. That's a water flow rate, inlet water flow rate. And suppose the upstream pressure here changes. Because of that, the flow rate may change, or the downstream pressure changes. That's why the flow rate may change. In that case also, we have to measure this flow rate, inlet flow rate. There you can implement one more feed forward controller. That also can be added to this. That also can be added to this. So, two feed forward controllers, one for steam flow rate, another one for inlet flow rate, inlet water flow rate. If any changes in that, that will adjust the valve opening to increase the inlet flow rate. In addition to that, level control, feedback controller is there that adjusts this valve. This is the boiler system with the feed forward, conventional as well as feed forward controller that we have seen. So all the three, this is feed forward 1, feed forward 2. This is feedback controller. So all are added together to adjust this valve. It will exhibit inverse response. So that you can write. How it will exhibit inverse response? Suppose you want to increase the level of this boiler means, suppose your demand increases. That's why level has to be increased because demand increases. That's why level decreases. To increase the level, this valve will be opened more. If the valve opened more inlet will come. If the inlet flow rate increases, what will happen? The temperature will decrease. That's why the boiling of this water will be quenched. So as the boiling of the water is quenched, that's why the apparent level is decreases. We know that while the water is boiling, the apparent level will be higher. The transmitter gives apparent level only, but apparent level goes. That's why there will be a, if you increase the inflow rate, level has to rise. Instead, initially it appears that level decreases. That is called inverse response. So, and in boiler, you can implement split range control also. Split range control also you can implement. Suppose for the demand, 2-3 boilers are supplying the steam. This pressure in that supply line will be maintained constant. So if the supply if the demand increases, the pressure will decrease. So we have to supply from additional boiler. For that, split range controller can be employed for this boiler system. Already we have seen split range controller for boiler. Already we discussed that you can include. So sometimes if they ask a short note on boiler system, you can write all these things. What and all you can write? We have to employ level control. We can employ feed forward control. for demand on steam as well as change in inflow rate. For the two feed-forward controllers can be implemented. You can write about inverse response. You can write about split range control. So these are the things you can write.